Welcome, everyone. In this episode, we are discussing accelerometer measurements in farm animals, how that data combined with health data can be used in AI models to improve animal welfare. And we have a great guest for this episode. He's working as associate professor and research chair at Dalhousie University in Canada. And his research topics and interests are digital agriculture, artificial intelligence, big data analytics, animal computer interaction, and sensors and bioinstrumentation. Ladies and gentlemen, please welcome Professor Suresh Neethirajan. Welcome, Suresh. It's great to have you in the podcast.
Thank you, Olli.
Thank you. It's great to have you. And maybe the same way as we start often, would you like to tell a little bit about your scientific background and how did you end up to the stage where you are now in your career?
Okay, thank you. So I classically trained agricultural engineer, and then I slightly shifted into biomedical engineering, master's PhD. I gained research experience in multiple continents. After my PhD from Canada, I moved to United States, worked there for the Department of Energy, Oak Ridge National Laboratory for a couple of years. Then moved to Japan. I was there at the National Food Research Institute in Tsukuba near Tokyo. Came back to Guelph, University of Guelph near Toronto for 8 years. I was a faculty. And then again, I moved to Netherlands. I was at Wageningen University in research for almost 4.5 years. Now back to Canada, which I call as home now. I'm an associate professor and also university research chair in digital livestock farming. I have a joint appointment between the Faculty of Computer Science and the Faculty of Agriculture. There are two campuses. The main campus is in Halifax City in Nova Scotia, and the agriculture campus is about 110 kilometers away from the city in a town called Truro, where we do lots of animal experiments. We have a ruminant animal research center, Atlantic County Research Center. We also have a few horses and mink. We have a bunch of sheep also we house. So we collect lots of data. So my research focus is primarily on how do we improve the quality of life of the farm animals and also cater to the needs of the farmers, provide sustainable profitability and improve the welfare of the animals through digitalization approaches. We use artificial intelligence, develop algorithms, look at a variety of multimodal data sound, audio, images, videos, accelerometer, acceleration related data, variety of data, and then even thermal data, biomedical, physiological signals, then create insights to better understand the lives of the animals so that we can develop decision support tools, a predictive analytical approach in terms of understanding the needs of the animals as well as the health and welfare of the animals.
Yeah, sounds very interesting. And we are physical activity research podcast, but we have been very biased to humans, so we haven't had much animal and livestock research discussions yet here. So maybe you can give us for our audience kind of a general view that how do you how do you study the animals? Maybe we can start with the accelerometry as that is closest to what we do with humans. And how do you do it? You have different animals. How do you place the sensors? What do you look, and how does this affect the quality of life of the farm animals? It's a multifaceted question, but you can start from somewhere which you see most fit.
Yeah, yeah. So the locomotion or activity is very important for farm animals. When we look at the intensive farm animal, there are two types. One is an indoor housed animals. countries like, Scandinavian countries like where you live, Finland, here in Canada, of course, many parts of North America, including United States. It's an intensive livestock. Animals are housed indoor, especially chickens and cows and sheep, etc. So sometimes we, based on the need, we also have to let the animal go outside for their own well-being. They do exercise for a few hours. There are two types of intensive livestock farming in terms of the animal husbandry or the housing systems. One is a tie stall for dairy cows, which means tie the cow to in stalls. They can stand, and most of the time their ability to roam around is limited. The another type of housing is it's not tied to anything, but it's an enclosure they can walk around on their own and enriched the husbandry systems. So it's a little bit better than the tie stall, and the whole livestock husbandry slowly moving towards providing more options for the animals to move around. So, because of locomotion, there are also issues like metabolic disorders based on the feeding that happens. So, there is a definitive need to measure the activity pattern of these animals, such as dairy cow. For chickens also, they tend to poach, they tend to move around because it's good for their heel bone so that the bone density is very good. So there is a need to measure the activity of chickens, broilers, and laying hens. Course, from the academic perspective, from the scientific curiosity, we can put on some accelerometers, sensors in the legs of the chickens. We have done that in turkey birds. We have also done in laying hens and broilers to measure how they move around. What we call as a migration coefficient, how many meters they walk per day, what part of the day, because the accelerometer data also comes with the date and timestamp. We also record their activity level in terms of the diurnal pattern, in terms of the, is it a early morning, is it afternoon, post feeding, fast feeding, what is their preferential way of moving around. For the cows, we did recently a project based on the beyond sensors we have got in the past 3 months. Put it on 6 cows, including the control cows. We were actually interested in the possibility of detecting what we call as lameness. Lameness is a health issue for dairy cows. So when a cow becomes lame, there is a bit of a hunch on the back. So it's not a normal. So, and also when we look at the gait pattern visually, they don't walk normally. There is a bit of limping happens in some of the legs due to the metabolic disorder, due to specific health issues. So, which means they cannot stand too long. They tend to lie down a lot of the time. So the idea here is that how do we go about using accelerometer as a possibility to predict yearly prediction possibility based on their walking pattern. So the idea here is that how do we go about using accelerometer as a possibility to predict yearly prediction possibility based on their walking pattern? Can we be able to say 2 weeks or maybe 4 to 6 weeks in advance before the lameness is going to happen? So that's the idea behind our project. So we collected a bunch of videos and images along with accelerometer data, put it on the cows for 6 months and collected for about 2.5 months of data. Based on the analysis, we were clearly able to pinpoint what we call as indicators of lameness based on because it has the sagittal, lateral, XYZ, 3 types of data we can apply from the accelerometer. We also have the ability to say, okay, what part of the body the cow lies down? Is it the right side of the body or the left side of the body? How long they are standing, how long they are sitting. They have continuous feeding availability. The feed is always available. The water is also available all the time. But when we connect the video data and then annotate the data and compare that the accelerometer data, we now have the ability to say before feeding and after feeding, what is their rest index and the activity level index changes based on the physiological needs, metabolic needs of the animal. So for the cows, we typically put the sensor in the hind legs or in the front legs so that we have so they don't get damaged. They can walk around. It's easy to measure. But we also have bought sensors from other brand. We have put sensors in the neck of cows, like a collar, and also as a ear tag along with the RFID. So, but that's a little more invasive if you put it in the ear. So neck is more like a garland or a necklace. We wrap it around in hand, but the leg seems to be working for us for this. For the sheep, again, it's typically the neck of the sheep or the leg of the sheep. For chickens, it's typically the legs. But again, practically speaking, it's not feasible actually to apply accelerometer sensor in a large scale for chickens because we typically house 27,000, 30,000 birds. So we cannot go and put. And second thing, it also impedes the welfare. We have to catch the bird. There is a bit of manhandling involved. They don't like it. They don't like to be touched. So for the cows, we do hoofing. There are all the time like a milking during milking process. So cows is a bit more easier for fitting accelerometer. The same is the case with large animals such as sheep and horses.
Mm. Sounds very interesting. I'm thinking like which part to start, but yeah, I think the cows are interesting, and you are looking the lameness, which is metabolic disorder, and there's a gait pattern, there's limping, and there's maybe differences in in the laying down patterns. So you said that there is some indicators that you can predict the lameness. What how is the data analyzed? What are the How do you analyze first of all the data? Do you segment the data to certain periods post feeding and so on? And how do you look? Do you use AI? Maybe tell us a little bit more about the analytics.
Yeah. So we do use machine learning, deep learning techniques for our data analytics. So, like, I know Fibion has a dashboard, it gives a bunch of graphs, but we were interested because sometimes in the early morning, 5:30 to 7 o'clock in the morning, we let the cow go out, they walk around. So, because the sensor was worn continuously for about a month, continuous data was being collected. And then during in the evening time, also the cows sometimes they go outside and come back in the summertime, especially for exercise. And also for milking process when they go for milking and come back to the barn. So we have specific labeling what time of the day they go for exercise because the water and feed is continuously available. We know that. We also know sometimes the animal caretakers come to the barn, so there is a more human presence expected by the cows. They know that okay, they kind of tune. And then there is also morning, afternoon, and evening. We clearly see that based on our data analytics, more activity they try to stand most of the time in the morning times. But then once it goes towards the evening, they tend to lie down. So the preferential activity based on the day, what part of the day, in terms of availability of, we're also able to connect that. So the after we collect all of these cumulative data, we do look for noises and anomalies if there is any missing data, and we take care of that or remove that based on the date and time stamp. After pre-processing, we use techniques like random forest technique, LSTM based AI approaches to look for the trends because it's always a comparative analysis. It's also context plays a significant role. We had control cow to 3 cows, healthy cows, which were not going through lameness. We have 3 cows which were actually going through lameness. We were also looking at the age of the cow. After the cow is born, we know the exact age of the cow. We also know what we call as DIM, which means days in milk, how many days they over a period of 365 days. Sometimes they go dry. or when they are going to give birth to calves, they don't give milk. So we know the number of days the cow is giving milk, the dry period, that information is also available. We also have a bunch of data based on the milk. Because we send the milk to a particular company, we collect data related to MUN is milk, urea, nitrogen, how much of calcium is present, other genetic parameters associated to it. So we correlate all of these health information to the lab in the consideration of accelerometer data. Because we collected video data, we also collected images of the faces of the cows. We were actually looking at, is there any visual indicators? For example, they tend to tighten their snout, clench their snout and tighten
Mm.
it. There is a bit hinting in the eye region. Sometimes you can say based on the ear posture, they are droopy, backward, forward, sideward. What is the ear posture? How much of eye white is present? We also developed an artificial intelligence tool, what we call as biometric facial recognition tech for measuring stress indicators of the cows, and we correlated that to the accelerometer data. Okay, because it's unimodal data. Accelerometer alone does not say much. Now we have multimodal data, data that comes from the facial recognition of the cows, data that comes from milk of the cows. So we combine the physiology, health, and the visual indicators along with the accelerometer to come using the AI-based model, XGBoost, LSTM, random forest, and other machine learning techniques. We were able to say, okay, now we can clearly differentiate between a lame cow and the healthy cow. These are the set of features that indicates the presence of lame in this particular context, provided they meet these are the specific criteria. We also develop what we call as the predictive tools. Is it possible for us to advise the farmers, the operations manager of the dairy barn, tell, hey, you know what? Exactly 6 weeks from today, this cow is going to go lean. Now is the time for me to intervention. I have to make some management strategies in terms of perhaps I have to allow the cow to walk a little more, change the feeding implements, the hygiene associated to it, or socialize with other cows so that the possibility of leanness can be drastically brought down. So it's a mixed strategies farmers follow. We advise them based on the input and the results we get from the data analytics of accelerometer along with other data.
Yeah, sounds very interesting.